Okay, so quick review about vectors, right? Really, you're only going to have to concern yourself with 2 or 3 things. You're going to have to know how to do a scale drawing, right, of a single vector. You're going to have to be able to, let me see here, add vectors. And I will just give you, on the upcoming test, I will just give you, take this vector and add this vector, and it's pretty obvious exactly what you need to do. Okay? Now there's 2 ways to sort of add vectors. One is by scale drawing. And that, of course, means in tip-to-tail fashion. And what would be sort of the second way that you can add vectors? And it only works in special situations, where the angles are 90 degrees, right?
Yeah.
A right triangle. So what would you call that way? By Pythagoras?
Yeah.
Okay, so the second way is by Pythagoras, the old a squared equals b squared plus c squared thing, right? And that, of course, also means that your angle has to be done by second function cat, right? Again, that would also have to be in a what kind of fashion? Tip to tail. Okay? Now, under adding vectors as well, there'll be some basic ones, and then there'll be some word problem ones. Adding word problems. Hello. Really? All right, so as I was saying, adding sort of in a word problem format. So it won't come out and say, add these vectors, you have to recognize it's a adding word problem. What kind of wording would I use in a adding word problem? Like, what would be an example? How would you know? Well, I suppose there would be words. Maybe, or like here's some examples here, right? A force of 10 units acts eastward upon an object, and a force of 30 units acts in a southward direction. What is the resultant force? Right? So the word resultant would be a good clue that you're supposed to add by vectors, right? It wouldn't eliminate subtraction though, because we do use that word resultant there. But basically, I think you will be able to recognize addition kind of thing. Why sound you talking when I'm trying to do this? Okay. Now the other thing you need to do that we talked about yesterday was subtraction. And I think I need to talk a little bit more about subtraction. Okay, subtraction is when you do what? Add the negative, exactly. And we can do that. There's 2 different ways again, right? Scale drawing and Pythagoras. Right? Same way. It's just adding the negative. Adding the negative, right? And obviously, if it's a straightforward subtraction one, you should know which one to subtract. Shouldn't be that hard. It's the one that has the subtraction sign of it, right? If it's a word problem, now here's where I need to spend a few more minutes with you talking about that. Okay? Let me just talk about subtraction word problems. Generally, you're going to see planes in the wind, and you're going to see boats in a river, in a current, right? You might also see the word displacement along with the word position, right? If it says this is the initial position, this is the final position, what's the displacement? Well, clearly that is a delta D is final position minus initial position. And I just need to... So what I'm going to do is I have a handed assignment, okay? This is what I like to call vector golf. It's my day of the golf course, or at least the first 4 holes. Okay? I will tell you that there is some vector subtraction here. Okay? You will find these challenging. Okay? If you haven't done enough work understanding vectors, you're not going to do well on these. Okay? So you need to do the miles. Now, I'd like to talk briefly about number 3. Okay? Because in number 3 it asks you what direction you have to hit the ball. Okay? So the tee box is here, right? And the green is over here. And we know what the resultant we want is, the desired result. The desired result is a hole-in-one, right? So we're going to label that resultant. Okay, does everyone agree? Yeah. So we know the resultant. Now, would you agree with me that the resultant is what we'll call the ball's vector plus the wind vector? Would you agree that the resultant is the ball plus the wind? Right? The overall resultant is whatever the ball speed is plus whatever the wind speed is. Do we know the resultant? Yes. Do we know the wind? How do I get the ball? Okay. Now, if I just had something like 10 equals x plus 4, I take the 4 to the other side and I do subtract. Right? So would you agree with me that the ball is equal to resultant minus wind? Does that make sense? So it's now what kind of question? Vector subtraction. And what do you have to subtract? You have to subtract the resultant minus the wind, which we know that means resultant plus minus wind. Right? Resultant plus minus wind. I'll leave you with that.